So, it says use the graph of f of x equals 3 to the x to obtain the graph of g of x equals 3 to the x minus 1. Now, remember transformations when we did them with quadratics? With the a, b, h, and the k?
Oh, God, yes.
Alright, well, remember I told you, if you know what a does, you know what b does, you know what x, sorry, not x, but h and k, it's always the same no matter what kind of equation you have. Guess what? Same thing here. So your parent one is going to be y equals a times base raised to the bx minus h, and then a plus k at the end. Okay? Now sometimes you'll see their base, they'll call it b for base, but that's different than the b that's up there with the x. Okay? So that's why I always write out base. So that's our general form. Remember, a and k will affect my y because they're vertical. A is your vertical stretch or compression, or I think we called it a shrink. Stretch or shrink. K is your vertical shift up and down. So they're going to affect your y-axis. Your y values. Anything that's with the x will affect the x. B is going to be your horizontal stretch or shrink, and H is going to be your horizontal shift left or right. But remember, with x, it always does what? The opposite, okay? So if it says x plus 2, we know we're going to subtract 2. All right, so looking at this problem here, it says use the graph of f of x equals 3 to the x to obtain the graph of g of x equals 3 to the x minus 1. What is that x minus 1 going to do to my graph? What is that minus 1? Is it horizontal or vertical? It's horizontal. Why? Because it's with the x. So is it a stretch or shrink, or is it a shift? Shift. Why? Because it's being added or subtracted. Okay, if it's being added or subtracted, it's a shift. So it's a horizontal shift. That horizontally, if we shift, we go left or right. So if it's a minus 1, which way are we going to go? Right 1. Good. It's always the opposite. So we don't go towards a negative 1. We go to the positive 1. All right, so when I graph that, I expect to see my graph shifted to the right 1 compared to what we just saw in the other example. So now I'm just going to pull my table from the other example there. Yours, I believe, is above. So we had what? Negative 2 and 1/9. We had negative 1 and 1/3. We had 0 and 1. And we had 1 and 3, didn't we? So for my transformation here, you told me it's going to be a horizontal shift right 1. So does that affect x or y?
X.
How? What are we going to do to our x's?
It's going to be...
It says minus 1, so what are we going to do?
Add 1.
We're going to add 1 to all of our x's. Is there anything that's going to affect my y's? No. And something I forgot to put down there at the bottom of my table was my horizontal asymptote. Remember, for the parent one, it was at y equals 0. All right, so we're going to add 1 to all of our x's. Our y's are not changing. What about my horizontal asymptote? Will it change? No, because it's a y equals, okay? It only changes if y changes. And then let's graph that.
Wait, somewhere?
Uh-huh.
On the x plus 1, the 1 equals 1 and 2 equals 3. How'd you get that? The x 1 equals 1.
I took all of the x's that were over here, and I added 1 to them and put them over there. So like negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0.
The y stayed the same.
Yeah, y stay the same. That's why I didn't touch them. They all just got moved over into the new table. All right, now I'm going to go ahead and I'm going to this time graph my original one on here just so we can see it. All right, so that was the original one. Now I'm going to graph my new one, my transformation. And does it appear to have just moved to the right one like you told me it was supposed to? It did, so there's our graph.